In this video, I'll demonstrate how we can make an RDS database instance in a private subnet available without the need for a VPN. Instead, we're using a modern-day zero-trust approach, which will provide detailed control and visibility to the administrator and ease of use for the database users. Best of all, I'll demonstrate how we can set this up completely passwordless, completely eliminating shared or static credentials. That means end users only need their existing single sign-on credentials to access the database, while the Border0 connector will use IAM Authentication to authenticate to the RDS instance. Let's dive in. This diagram shows the setup we're working with. We have the Border0 connector in the middle and an RDS instance on the right-hand side. This is all hosted in a private subnet, and we'll use Border0 to make the database available to our engineering team. I've already created a RDS database, as you can see here. Again, this sits in a private subnet. Now to the Border0 portal, as you can see here. I've already went ahead and created a database socket. One of the things to notice is that the authentication type we're using for this socket is username and password. Now, in this example, I've elected to store the credentials in SSM, so the connector will request them on the fly when a user connects and provide credential brokering. This way, the clients can simply access the database using their SSO credentials. As you can see, I can already access it. I have a demo database here called Books, and we can browse the data in the various tables. Okay, now that we have access to our RDS database, it's time to further enhance our security by enabling IAM authentication. This will ensure that the Border0 connector doesn't require any static credentials and completes our passwordless journey. We'll simply follow the instructions listed on docs.border0.com. Once there, select Expose a database server and the search for access to an Amazon relational database service. Finally, we go to the IAM Authentication section and follow the instructions. First, we create a new database user that will be used for IAM authentication. The next step is to grant privileges to our Books database, so I'll copy-paste this and grant all access on Books for this new user. Finally, we'll flush the privileges and make sure it takes effect. Next up, we need to make sure that the RDS instance has IAM authentication enabled. I used Terraform to install the connector into my Amazon environment. This should have configured the IAM permissions correctly. Just to be sure, we'll double-check everything. As you can see, I already enabled IAM authentication on my database. And second, we need to make sure that the Border0 EC2 connector has the right role. Here is my role, and this is what that looks like. You can see I have an RDS connect statement that allows the Border0 connector user access to the RDS database. All right, we have now configured everything on the Amazon side. The last step is to update the Border0 configuration. We'll go back to the Border0 portal and edit the database socket. The only thing that needs to change is the authentication type. Instead of username and password, we'll use IAM authentication. We'll also change the upstream username to the database user we created earlier. Everything else remains the same, so we'll just hit Update Socket. This change will be pushed out in real time, and so we should now be able to test our new passwordless configuration right away. To verify that we're using the new credentials, we can use the Select Current User query. This indeed shows that we're connecting with the newly created database user. As you can see, browsing and executing queries is the same as before. Best of all, users can use the Border0 web client, a secure client that runs fully in your browser, or use your favorite database client. We've made that easy too by integrating with most popular clients. This is awesome. We're now completely passwordless. End users can connect using just their single sign-on credentials, while the connector is granted access just based on its IAM role. Next up, let's take a quick look at Border0 policies and how they can be used to control who has access to the database, as well as what type of queries a user is allowed to execute. I will log in with my Google account. I can now see all the resources that I have access to, based on my single sign-on identity and the Border0 policies. Let's click on the RDS database. Just like before, I can browse the tables and select data. Let's try and delete an entry from the books table. As you can see, the Border0 policy is preventing this delete query from being executed. I can also try and drop the table, but as you can see, this query is also disallowed by Border0. We should now be able to see the queries we just executed in the session log. Let's go to the portal and find the current database session. Here, we can now see all the queries we just executed, including the failed delete and drop table query. As you can see, they were denied by policy. Let's browse to the Policy tab and take a quick look at the policies attached to this socket. Here we see that the policy that's attached is called Database Read Only, which only allows select queries and a few other read-only type queries. Now let's attach an additional policy. Here I'll select Database Full Access, which should give me full access to the database. Now if we go back to the database and try the same delete query again, you can see we are able to now delete items from the database. Notice how Book ID 1 has indeed been deleted. Next up, we can also drop the table called Books. Let's validate that with a Show Tables query, and notice how the Books table is missing now. When we go back to the session recording window, we can see a live report of the queries. Notice how the delete and drop query are now listed in the query log as successful queries. To wrap up, in this demo, we showed how we can achieve a fully passwordless experience for RDS in a private subnet using Border0. We saw how users are able to access the database without the need for a VPN and using just their single sign-on credentials. And no point do they need to know a shared database credential. The Border0 connector will authenticate to RDS using IAM credentials, making the whole setup passwordless. And the connection between the client and the connector is end-to-end encrypted. We also saw how administrators have full access to session and query logs, giving them detailed visibility into who accessed the database, when and from where, and what queries were run by whom. Finally, we saw how we can use the Border0 policy engine to control what level of access different users should have to the database. Border0 takes care of the complexities, allowing both administrators and engineers to focus on what matters most. The end result is a solution that boosts productivity and is easy to use without compromising on security. We invite you to experience these benefits firsthand by exploring Border0's free, fully functional community edition and see for yourself how easy it is to start your zero trust journey.